Hey guys, I want to talk today about important ordered pairs and other values in proportional relationships. This will be simple but new, the ordered pairs. And then I want to connect that to this, which you've already learned, and really just kind of put some ideas together that hopefully make this whole proportional relationship idea fit together. I want to take some things that I think may have come across as a little bit separate and kind of combine them here. So make this your next title and close up your math notebook and give me your total concentration when you have done so. Alright, so here we've been dealing like all week with this problem with the blue and the green tiles. That was our kind of our first proportional relationship, and I just want to remind you about it. And a few things that I want to remind you that we learned. One, we could tell it was a proportional relationship because in the table, the constant of proportionality was always 3. Kind of stayed the same every time. Here, because of that, since it always went up 1, then 3, 1, then 3, 1, then 3, it made a straight line on the graph. Those kind of go together. And it also went through the origin. And that's how we could tell it was proportional here. Same thing there. We had 0, 0. That's the same as the origin. And straight line is the same as going up in these equal ratios. All right. So let's keep with this since this has been our example and it is a handy one. And so I want to ask you some other questions about this and tie a few things together. So here's the same graph of blue and green tiles. And we've already found the constant of proportionality in this one. And it was 3, so I want to start there. And so I want to talk about a couple other things you can do. So the first thing is knowing this constant of proportionality. It says write a sentence describing the relationship between blue and green marbles. So this is actually a sentence I want to talk about. And because this constant of proportionality has to do with the situation, it's not just a calculation we find. It tells you something important about the problem. So if I were to look at this situation, say every time I add 1 blue tile, I add 3 green tiles. That's really what's happening in the problem. I would say for each blue tile, I add 3 green tiles. And the reason, I know that's a simple thing to say, but if you can write a sentence like that, what I want you to notice is the constant of proportionality ends up in the sentence. Another sentence I could have written that also involves that number 3 is the unit rate is 3 green tiles per blue. If I want to think in terms of unit rates, I could have said that sentence too. And again, there's a 3 in there. The constant of proportionality is the key to the ratio. If you have a proportional relationship, that number means a lot in the problem. And so sometimes it's a good exercise to verbally explain the sentence, verbally explain the situation, because you'll see the constant of proportionality there. And that's actually another way to even find it. Okay? So that's sort of just connecting those ideas. Continuing in there, anytime you have a graph of a proportional relationship, the x equals 1 ordered pair is an important one. So if I look on the graph, the x equals 1 ordered pair, this is my x-axis right here. So I want to look where x is 1. That is this ordered pair right here. That is my ordered pair on my graph where x equals 1, and that on this situation happens to be 1, 3. That's my x equals 1 ordered pair. So it says, look at that. How does this relate to the first 2 questions? And so if you think about that, that is an ordered pair that tells me when 1 blue, 3 green, right? And that's all that ordered pair means. When there's one blue, there's three greens. And I picked the x equals 1 ordered pair because, check it out, that's my unit rate. Unit rate is whenever you have a 1 of the x value. When I look back up here, for each one blue tile, I add 3 green tiles. 1, 3. The unit rate is 3 green tiles per 1 blue, right there. So that is my unit rate point, or my unit rate ordered pair on the graph. If I look at that x equals 1, I get all the information about the problem, which is pretty cool, all in there. The constant of proportionality is in there. 2, the 3 is the constant of proportionality. It's the ratio. It's the unit rate. Like, everything is in this one magical point there. So always finding your x equals 1 point is really cool and tells you a lot of neat information about the problem. All ties together. The other important point that we've talked about a little bit before is the ordered pair 0, 0. If you have a proportional relationship, that ordered pair has to be there. That's this one right here. We call that the origin, or 0, 0. And that, what does that ordered pair mean in the situation, and why is it important? And the answer to that is, that means if 0 blue tiles, 0 green tiles. That's all that means. And that has to be included for a proportional relationship. It's not enough for a proportional relationship. Just because 0, 0 is there doesn't mean it's proportional, but it's one of the main things, is you've got to have a situation where 0 of one thing means 0 of the other thing. Okay, let me do one more before we do it together. If I were to ask all the same questions, remember I've been bringing up non-proportional relationships, just to remind you that just because you see a relationship doesn't mean it's proportional. This is a great pattern, right? You see this, it is in a straight line. So that means it's growing in a pattern that you could predict, right? Looks like every 10 years, if I go over 10 years, I go up about, what, 8, that would be 4, maybe 12. So maybe like every 10 years plus 4 feet, something like that. That's a great pattern. Add 10 years, add 4 feet. Add 10 years, add 4 feet. Add 10 years, add 4 feet. But there's no origin here. So this is not proportional. If it were, to be proportional, I need it to be 0 feet after 0 years. But when they planted this tree, whenever they planted it, it had already started growing. So at 0 years, when they started measuring, it was already about 10 feet tall. So this is not a proportional relationship. 0, 0, I need that for proportional, and it's not there. All right, open your math notebook. Let's look at a graph together. Go ahead and pause and write down the graph and write down the questions. I think we looked at this one yesterday, Anthony's rate of speed. Once you've got the graph drawn and the questions written, unpause and we'll go over them together. All right. So write a sentence describing the relationship between time and distance. So when I look at his running, every time I add 1 minute, he goes 200 meters. 1 minute, 200 meters. 1 minute, 200 meters. So a couple sentences I could write would be, Anthony runs 200 meters each minute. That's a unit rate. I could also say, when I add 1 minute, I add, let's not say I, when 1 minute passes, he runs 200 meters. So every time 1 minute passes, he runs 200 meters, something like that. There's just some way to talk about the situation of this ratio verbally, so you can explain what's going on. If I find the constant of proportionality, remember from a graph, one of my strategies to find the constant of proportionality was just to pick any one point. Let's say maybe that one. That's 3/600. And calculate, since I can tell this will be proportional, it's straight and it's going to go through 0, 0. I can do that constant is y divided by x, which is 600 divided by 3. And you probably know where this is going. What's it going to be? It is 200. And I asked you to do that because, look, you already calculated it. If you write a sentence like this, you already found the constant of proportionality, which is equal to the unit rate. It's all the same thing. It's different ways to interpret the same number. It's 200 per minute, but it's also an increase of 200 each time a minute is added. So it's a way to continue the ratio, it's a way to get the unit rate, it's a way to understand the ratio, and it's even a way to explain the ratio. So that 200 is just a really important number, and it appears in all kinds of places. Speaking of that number 200, we're going to look at that point on the graph next. So when I look at that point right here, I like to call that my unit rate point, because that's where x equals 1 minute. Remember, a unit rate's got to have a 1 in it, and it's a 1 on this variable, on the independent variable. So this is where I would find, if I look at that point, 1, 200, that is the unit rate right there. X equals 1 minute, y equals 200 meters. Because he's doing 200 meters per minute. That's what's going on in the situation. So again, this 200 keeps appearing everywhere. It's the constant of proportionality. It's the unit rate. It's the first point on the graph. It's just a really important number, and it just keeps popping up because this stuff's all connected. So I like to call this the unit rate point. We always look at the x equals 1 point, because that's going to be where my unit rate is. So if I hadn't done anything else, and I said, what's his unit rate of speed? Well, boom, you just look at the x equals 1 point, 1, 200, and that's your unit rate. Ultimate shortcut, if you know how to do it. And it's the constant of proportionality, no less, all the same thing. All right, and last but not least, what does the ordered pairs 0, 0 mean, and why is it important? It is important because it is necessary for a proportional relationship. And it is right here. And what it means is 0, 0. 0, 0 means 0 minutes equals 0 miles, or 0 meters rather, right? And it's just a logical point in a proportional relationship, that in any proportional relationship, when there's 0 of one thing, there's 0 of the other, or you don't have a proportional relationship. All right. So that is proportional relationships, and that is how that this important point and this important point factor into everything so far and how it all goes together. If you need to go back and watch either example, please do. Make sure you come to class with a great understanding of this complicated relationship, and I'll see you then.